of dollars of investments and acquisitions happening each year, entirely done by spreadsheets and emails. And furthermore, when we talk to founders, investors, and early employees, what we see is that a lot of times there's mistakes. You see spreadsheets with errors when they're created by founders. The single most valuable asset for so many people is the shares in the company that they work for. And the tools to manage this today are broken. So that's why we created Pulley. With Pulley, we help companies and founders never have to worry about cap table management. And at Pulley, we help all of these hypergrowth startups manage their equity in an easy way. So when you're building a cap table management tool, there are two things that you always have to get right. The first is to never lose customer data. And the second is you need to maintain an accurate record of who owns what. And in this talk, I will focus on how Pulley was able to build a new way of storing information on a cap table so that we can make sure this data is always accurate and cannot easily be corrupted or interrupted or misinterpreted. So at first glance, when you think about maintaining data on a cap table, it may seem really easy. If you're an early stage company, you maintain your cap table on a spreadsheet. You just easily record who owns what, the number of shares that you have. Translating a spreadsheet into a database seems straightforward. But the problems that you face really with maintaining equity on a cap table is what happens at scale. As companies grow, their cap tables become increasingly complex. For example, you have many different types of share plans and many different types of share classes for employees and for investors. And once you grow, shares can also be transferred, repurchased, canceled, exercised, converted. There's repricing, there's stock splits. And on top of these, all of these different state transitions can also be combined with each other. Managing all the logic across a company's cap table ends up becoming really challenging. And every time you add a new action, you have to consider the combination of different events that can happen on top of all the previous actions that you already support. So we think about the second requirement of building a cap table of always being correct and making sure that the data on your cap table is accurate. Satisfying this requirement ends up being non-trivial. So let's walk through a quick example. Meet Betsy. Betsy joins a startup as their first CEO, and she receives options. Her options, like most options today, are vesting over 4 years with a 1-year cliff, meaning that she gets 25% at year one. After her options vest, Betsy has the option to exercise her options and receive shares. And as the company nears IPO, it turns out they're doing really well. So what Betsy wants to do is take those shares and transfer them into a trust for her family. So Betsy has some pretty simple questions. How many shares of the company do I actually own? How much are these shares worth? What happens if the company does another round of funding? How do I model all of that? And then for the company, Betsy is also just one shareholder. There are many other employees like Betsy who want to ask the same questions, and employees can also leave and rejoin a company. So complicating kind of the data model that you have to manage. As we kind of looked at all of this, one way that you can kind of model all of these transactions on a cap table is sort of through a simple database where you list out what the transaction type is and what the amount is. But as we can see kind of on this next slide, there's a few problems with this approach. The first is that we realized that engineers need to be cap table experts in order to make this happen. You need to have a deep understanding of how a cap table works in order to be able to handle all different state changes that can happen. So this is a quick screenshot of one piece of code with Pulley that just pulls in how much fully diluted shares an individual has. Making sure that the calculations are correct as you add more actions ended up being really difficult. The second challenge that we faced with this approach is that dealing with future events was really challenging. With cap tables and vesting, it turns out that we need to record not only the past, but also the future. When shares are vesting in the future, many times companies also want to query for, well, how many options will already have vested in a year from now? And doing that with a standard model wasn't very feasible. And the third was that development was slow. So as a startup, what you want to do is move really quickly. And if you remember that one of the two most important things is that we can never make a mistake, turns out trying to move really quickly and not making a mistake was not really two things that combined together. So thoroughly testing every new feature we added took a lot of time. So this naive CRUD database approach was slowing us down. And that's where we decided to go back to the whiteboard and kind of look at how is it that we can build a new way to record cap table data and so that it's both accurate and allows our engineering team to move quickly. For Pulley, we took a lot of inspiration from double entry accounting. Double entry accounting is a system of bookkeeping where every entry in an account requires a corresponding and opposite entry to a different account. And what this allows you to be able to verify that accounts, that all the data within the system are correct because all the debits and the credits must match. If you think about modeling a cap table as a double entry accounting system, we can quickly verify correctness. We can always know that the number of shares that's issued within the company can never appear out of thin air, as well as shares can never disappear into thin air. So for us, when we kind of look at double entry accounting, while it's a really great starting point, there are a few places that we needed to kind of look further into, where the standard off-the-shelf systems didn't work well for Pulley. And the three are: one is that we need to be able to query for state changes. Oftentimes when you're using double entry accounting, it's a standard money ledger where all you're concerned with is account balances. For Pulley, we want to not only know the balance of account is 100 shares, that's not enough information. But rather, we also want to know how many of these shares are vested, how many shares are unvested, how many of these shares have been exercised. The next is fungibility. Most of the times when you're building a ledger, you're dealing with entities that are fungible, such as dollars, but securities themselves are not fungible. So we needed a different way to be able to model this. And the third is time. So as we mentioned, we need to record not only the past, but also the future. Double entry accounting systems only record things that have already happened. So we needed to build a different system to handle that on Pulley. With Pulley's flexibly immutable ledger, what we did was be able to create a way so that we can record transactions of different state changes when it comes to securities and model that easily on our system. So I'll walk through how the ledger works. The first part of it is that we record an account. Account is simply who owns what within the company. The second part of it is a debit and credit. Every time shares are transferred or issued, there is a corresponding debit and credit. So going back to double entry accounting. So for this example, what you can see is that when we have unvested shares, when they vest, they move from an account for unvested shares into account for vested shares. Again, one of the benefits that this allows us to have is that we can make sure that all the debits and credits within the company align and balance out to zero. Next is activation date. Activation date is a unit that we introduced to be able to know when transactions take place. This allows us to be able to record not only the past of what's happened on Pulley, but also the future. So in this way, we can query the cap table at a time in the future of knowing in a year when additional shares vest, how many employees will have those shares and how many shares will be issued out of the equity plan. And then the last part is the nonce. So the nonce is the part that's most interesting because it allows the Pulley's ledger to be flexibly immutable. With our append-only ledger, oftentimes there's immutability is a constraint. So one of the benefits that we often get with the nonce is that it allows us to be able to make changes because there's human error that often occurs. Information can be recorded incorrectly on a cap table, and the nonce allows us to be able to effectively undo these. So there's three characteristics that we have when building Pulley's ledger and that the nonce introduces. One is dependency. We introduce this concept of read after write after read behavior. So every time a new transaction is written, we have to record the nonce of the previous transaction. This allows us to be able to see the entire chain of transactions that have happened on Pulley. So if we wanted to delete a single transaction, what we can do instead is be able to see what are all the transactions that depend on it and delete all of those as well. It also allows us to be able to support multiple writers. We have an optimistic locking scheme so that only one transaction can be written. And the last one is idempotency. With a nonce, we can also ensure that only a single transaction is written, and we can also rerun the transaction and ensure that the cap table still is in a valid state. So we showed you at the beginning of this talk, this is what it took to calculate Betsy's shares. 200 lines of code of extremely complex math to make sure that the numbers are correct. By building this flexibly immutable ledger, what we have now is much simpler. In order to know how many shares an account has, it is just the sum of all the credits minus the sum of all the debits. Significantly easier to work with and allows us at Pulley to make sure that the data is correct as we add more actions too. So going back to kind of top level design goals with our in-house ledger system, we can meet the design goal of making sure we never lose the data with an append-only ledger and always be accurate, of making sure it's easier for our engineers to also be able to add in additional actions quickly. And most of all, we can move far quicker and be able to support more companies as they scale. So the ledger is one of many company projects that we're working on at Pulley. We are also building out a system to be able to extract data from PDFs to make it easier for data entry. And for Pulley, there's a ton of things that we really want to build, and we're growing really quickly. So we're looking for more entrepreneurial engineers to be able to join our team. 100% of our founding team has started a company before, so we're looking for more founders and more future founders who want to come on board with Pulley. And for us, one thing we really value is folks that are driven. So at Pulley, we look for drive over the credentials that you may have. So to wrap up the talk, I'm Yen. I'm the founder of Pulley. We'd love for you to stop by our booth and to meet some of the folks on the team.
Awesome, Yen. Thank you so much. And next up, we have Steph and Darren from LogDNA to share more about what they're up to. You guys want to take it away?
This is Sven from LogDNA. I just want to give a quick introduction. My partner Darren next to me, he's one of my top engineers. Instead of me talking about all the wonderful things that LogDNA does with logs, which is, well, we store people's logs at scale, right? 18 petabytes of raw storage, 3,000 Elasticsearch pods running in the cloud there. I'd rather have him talk about some cool stuff that we're doing to make sure that our customers get a good user experience and that our product is stable. That's the kind of stuff that engineers will do day in and day out at our company. And so I figure that gives you a very good perspective on what's going on. So with that, Darren, have fun.
Thanks, Sven. Yeah, today I wanted to talk a little bit about integration testing in a SaaS environment and share with you some of the tools and, oops, can you hear me? You should share with me some of the tools and techniques we use at LogDNA to get the job. Oops. Let me open up with a quote. This is by an anonymous source, but it rings true. It basically says that code coverage is not the be all and end all, right? But it's the place to start. It's not going to tell you that your application works, but it's going to surface bugs. And I can tell you from experience that you'll get a lot less Sev1 production calls when you have a good test coverage, good coverage in your test suite. So let's talk a little bit about some of the techniques we use at LogDNA. So tip one, testing, easy testing comes from testable code. For me, testing isn't really about testing, right? It's about making your code testable. The test suite needs to be able to traverse all the code paths to get a high level of coverage. So in this example, it's JavaScript for all of you out there, but it really is kind of pseudocode. This example accepts a context object and it calls a couple of functions off of that. The problem is, as the tester, I don't know what the shape of that object is. I don't know where the functions come from and how I reproduce it in a test. So that kind of thing makes it really difficult to test, and it makes it really messy if you figure out how to get it done. The second problem is that there's no way to surface errors. There's no callback or anything for this setup. And it's really important that the test suite be able to see every single error that happens so that you can have it tested. And this doesn't do that. A better way to set it up is to modularize your code so that each thing can be tested individually. And here, as the tester, I can see that there's no real dependence. It's pretty much a straight implementation that can be tested straight away. Tip two, the application should exit cleanly. This one's important. If you're using process.exit in your code, you should probably stop. It's kind of like powering off your computer without a proper shutdown. That kind of thing can cause race conditions, corrupted files if you're reading from disk. It's just not something that you want to do. A better way is to keep track of your servers and any timers and things like that and properly close them when the shutdown function is called. Here we've got a timer that runs on an interval. We save that into a variable and that can be cleared. If the server is listening, we close the server. And in Node.js, when the event loop is clear, the process exits cleanly, and that applies to pretty much any language, I would think. So that's definitely what you want to see. Let's talk about environment variables, right? They're powerful, we love them, they're global. They need to be pre-processed though, because really they're just strings. So chances are you're going to want to validate those things. You're going to want to see if someone set it at all. If they did set it, you probably want to coerce it into some sort of type, some other type. Like here we have a number and a Boolean. Having a constants file that looks like this is just really messy, and it's probably not something that's great for testing. A better solution, and this is something we've developed at LogDNA, is to have a parser that parses this out ahead of time. This we just called it config. It's an extension of JavaScript's map. And so it will read the environment variables, but it allows us to be specific about the types. It allows us to set defaults and describe for whoever's reading this what this thing does. And so since it is just a map in the code, you can call config.get and whatever key you want, and you'll get a pristine copy of whatever the value is supposed to be, whether it's a default or someone actually passed a value. So this is a big one. Function parameters can override settings. In this case, you know, well, in a lot of cases, your code will be using these environment variables, right? And here it's using a health check interval to set a timer for how often to do the health check. This thing could be anywhere from a few seconds to several minutes, and your test suite will be subjected to that value. So if you can't easily override these kinds of things, it makes it really, really hard to test. And in Node, overriding environment variables is particularly sucky. So a better way to do it is to have what we call a config-driven setup, to where your functions essentially take parameters for these things. If I pass something in, it uses it. If not, call the config getter and get whatever the default should be. It's important to note here that this is important for the test suite because there's a server involved. In the test suite, you'll want that port to be 0 so that it binds on a random port chosen by the OS. And it's because if you have thousands of tests running, chances are you're going to have any number of copies of this same server running at the same time. And so they have to be, they can't run on the same port, obviously. So this allows flexibility to do that. On line 20, you can see a specific Node.js trick that says if I'm running this from the command line, then call the function with the default port that we would expect. And so it's an easy way to separate test from a production environment. Tip 5, feel free to develop tools to help your test suite. Certainly in a SaaS environment or a microservices environment, you're gonna have to be making HTTP calls to get all sorts of things and to create resources. Here, this is a test that wants to do something with a customer and employee, but you have to go create all those things. Cutting and pasting this kind of stuff throughout every test is really cumbersome, and it makes for a really, really lengthy test. And the longer it is, chances are it's harder to manage. And so it's just not a great way to do this kind of thing. At LogDNA, we developed something called the setup chain. This is an async await task queue, which basically is a chainable thing. You can chain these function calls onto each other, and when execute is called, at that time it runs through and executes all of them in order and saves the results in the state object. So this is 5 lines of code, and a basic rule of testing is every test should set up and tear down its own data. Doing this kind of thing makes it easy to do that. This is a big one, testing against the real service when possible. When you're testing in a SaaS environment, you should be spinning up the actual services if you can. In this example, the user service is some other service, but we have a Docker image of it. So spin it up. Here we're running version 6, whatever the latest version of that is, and we're spinning it up. There's no substitute for the real thing. So this is definitely, if you can, this is what you want to do. And it also plays nice with the config-driven and the config parsing of the environment variable. These kinds of things play nice with Docker because on line 28, you can see we're just setting the service URL for this thing to the Docker container, and everything works straight away. It's really easy. The only thing you have to do with this approach is to bump this from 6 to 7 to 8 to whatever the latest version is. But that's really what you want, because there could be breaking changes in there, and you want your test suite to break when those things happen. So again, there's no substitute for the real thing. If you can't spin up the servers, if you're using a third-party application, for example, you should use interceptors to intercept the HTTP traffic. A favorite one of mine is called knock, and it's basically what it does is it's still a mock, but it's only mocking the server and the server's response. So here we're using the setup chain to set up 100 users. Let's say that our user creation calls out to Gravatar to see if they've got a Gravatar image for their email. Clearly, you can't do that in CI/CD, nor would you want to. So this will intercept those and send a 200 reply back for each one, and it works smoothly, and you're good to go. The big win about doing this kind of thing is that you don't have to mock an entire function, and you don't have to skip any lines of code. Your HTTP agent can stay as is. Error handlers all fire, everything fires, and all those things can be tested so that you can get 100% coverage. And that'll conclude the presentation. Thank you. Stay tuned to our LogDNA namespace and NPM. We are gearing up to release a couple of these products that we've discussed today and make them open source. So thank you very much.
Thank you, guys. And next up, we have Jeremy, who's going to talk a little bit about, writing software and starting startups isn't always the cleanest, but you got to do what you got to do to get it out there, help you be successful. Jeremy, you want to take it away?
Awesome. Thanks, Ryan. It is really nice to meet you all, and I appreciate the invitation. My name is Jeremy. I am the head of our product and engineering organization at Rippling. And I'm here mostly a little bit less on like the actual technology and more on just kind of what we do and why that makes for some interesting engineering challenges over the next decade. So I want to start with like, why does Rippling exist at all? And if you're a small business or a medium business or a large business, there's just a bunch of different systems that you have to have in order to make things go. And these perhaps a benefit system, so you can give them health insurance or something like that, or perhaps time tracking, or maybe on the IT side, it's more about like identity and security or kind of device management, things like that. So most companies end up needing to get like a bunch of these systems, like it's just payroll over there, HR, benefits, all the rest. The problem is that all of these systems own like one little part of the employee data or the employee experience. Like there's some stuff in payroll, there's other stuff in HR, there's some stuff over in identity. And for each of these systems, there needs to be like these custom integrations that are written between all of them, and just in order to do like basic things like keep the data in sync. And so the IT organizations at these companies, or if they're small, like the founders, right, have to spend a bunch of time worrying about either these integrations or kind of at best like pushing data around and keeping it in sync and figuring out which one's going to own it, which one's not. And furthermore, you end up with this problem where you have a bunch of like fundamental concepts that need to exist in multiple systems, like permissions, which might exist perhaps in the identity system, but then those permissions need to be like replicated and aligned with the permissioning systems in all of these other systems. And that's a pain. And this is perhaps a really kind diagram, because the number of lines here is a lot less than you actually see. And of course, there are many, many more systems in this. So Parker Conrad, who founded the company, his key insight was to say, look, the right way to solve this problem is to have just one system of record for all of this data, not a dozen. And so Rippling was founded on the thesis that in order to really transform this industry, provide everyone with a better user experience, reduce all of these kind of integration costs, you had to create a single place for all that. But you can't just say you own the data, because no one's going to use you if you just own the data. So you have to go about actually building each of these systems. And so you start with something like a basic HR system that allows you to kind of onboard employees when they have changing life events, like they get married and stuff, you make changes there. And of course, when they offboard, you kind of cleanly do that set of stuff. Then you need to pay them, and you need to do benefits, identity, devices, all these things that I mentioned earlier. And the key here is that we had to build each of these systems from scratch, or more accurately, are building each of these systems from scratch. And the reason this becomes compelling is, number one, each of them immediately has access to the information in that core employee system of record. There's no more integration between the systems. They're all reading from the same place. And anytime a change happens in that core system of record, it can get reflected back out to all these other systems automatically. Now, of course, any company of any scale needs more systems than this to survive. And so there's a whole bunch more, some of which we're building now that I can't quite talk about, others which will come in the future that we're going to need to build. But also we're not going to build everything, right? And so there is this like large ecosystem of other things out there that we need to have a clean API to, that can kind of come back and talk with that same employee system of record in a much, much cleaner way than people do today. So this is essentially what we are trying to build at Rippling. Now, why did I entitle this presentation like cutting against the grain? Well, the convention when starting a company is pursue a really narrowly defined objective, like crush it, find a fanatical set of customers. The insight that Parker had was like, you can't actually do that in this case, because in order to create a single system of record, and in order to make that truly valuable and to work as well as it can, you need to build all of these systems on a first-party basis. And so that's what we've been doing, and that's what we continue to do. And it's fundamentally why I got interested in the company, because it means that we have a whole bunch of really interesting challenges to solve in a really entrepreneurial way. And you think about Rippling today, which has less than 100 engineers still, and we're building all these products. Each one is really small, really entrepreneurial, and has to compete against these entrenched players. Like in payroll, ADP is a $40 billion company. Paylocity is a multi-billion-dollar company. And so each of these teams competes against like these very large and entrenched incumbents, which I think is a rather fun game to play. So what does this mean overall for engineering? Well, it means that it means we're scaling to support hundreds of millions of employees. This is going to be a global thing. We're not only supporting tech companies, we're supporting all companies. So restaurants, hair salons, chains of various kinds. And so it's really fun to be able to interact with kind of all these different kinds of customers. One of our key advantages is that we're building out a core technology platform that can be leveraged across each of these applications we're building. So when I was talking about things like a permissioning system, that permissioning system can be built once and then re-leveraged across every single one of these things, so you don't have to re-implement it many times. And there's a bunch of interesting stuff happening here that we're releasing over the next 3 to 6 to 9 months. We're going to have an extensive developer community. One of the things we're really excited about is next year, maybe the following, we'll start having our own sort of equivalent of Dreamforce, right? And so we're really excited about building that out. And then last and not least, of course, we have a couple of dozen other products we need to build. And so we're trying to get really, really good at repeatedly building and launching new products where we just know that there's already going to be a fit for those products in the market we serve. And we're hoping to kind of leverage the success of our current products to make those successful as well. So there's a lot going on, and I didn't want to pick just one thing, but I am very happy to kind of, in either the lounge or some later time, chat with anyone who would like about what we're doing and why it might be interesting. So thank you very much for the time, and have a great rest of the day.
Thanks so much, Jeremy. And next up, we have Tom and Omri to share more about what's going on at Routable. You guys want to take it away?
Hey everyone, good to meet you. We are Tom and Omri from Routable, and we are going to be talking about building a integration forward company. And basically what that means is we build a lot of fun integrations that are challenging and make our life harder, but our customers' lives easier. So the first thing I'm going to go over is, what is Routable? We are the simplest way to send and receive business payments. If you think about it at a very high level, today, it's really easy to send payments to consumers. Think about Venmo. It's like sending a tweet. But unfortunately, a business payment is like trying to move a bill through Congress. It is complicated, it is convoluted. One of the biggest things that we work on is helping your teams, finance, operations, and engineering, work together to send business payments that make your vendors and customers happy, but also update all the finance data that's associated. In turn, we help customers go from 1,000 business payments a month to 1 million business payments a month really easily, where before they would be making a hodgepodge of internal tools that suck. So where do the integrations fit in? At the end of the day, everything that we do at Routable is about integrations. And the reason we wanted to do this presentation is to really explain what does an integration business look like. I think a lot of you are probably familiar with Segment, Intercom, other tools like that, Salesforce, that are heavily dependent on integration. And when we went to build this business, we knew in advance that we would be building on top of integrations. If you can see here, Routable sits in between business tools, accounting tools, and human tools, and it is our responsibility to be the best steward of information between all these different channels. And that's what our customers rely on us for. This is important because at the end of the day, our customers need to know that they can rely on our business to be the source of truth for their biggest pain point, which is moving customer data. And the biggest thing that we found out over time is you can't have a crappy integration. You can't have a part sync. Sending data between two systems is really important, and it has become a big part of everything that we do, from design, product, engineering, and customer success. And this is really important in industries that are around high volume payments. So if you think about food delivery, insurance payments, even sending payments to artists on Spotify and stuff like that, it is critical when you're sending data between an ERP, a business tool, and your own platform for that data to be always in sync. This also makes our customers happy because they know they can build on top of our platform. At the end of the day, the best integrations win customers. Our business is about building the best engineering company in a very clunky B2B space. And the way we have started to win and really differentiate ourselves from our competitors is by putting a lot of focus and passion and attention to building the best integrations to make sure that people can build on top of our platform and not just use it with manual data entry. One of the things that I want to share with you guys is that Tom and I, when we were building this platform a long time ago, found our secret sauce. And that was that we realized that a B2B payment is the same thing as a pull request. We realized that instead of changing a code base, you're changing a bank account and an accounting software. You're making modifications to those two places. There is a review cycle when someone can say, yes, I want to make this change. No, you made a mistake. We're moving money to the wrong bank account. Then there is a CI process when we check bank accounts, we check validity of payment methods, we ask the bank if the transfer can go through. And then there is the merge process where we actually try to move the money and then update the accounting software after the fact. Once we learned this was our aha moment, that's what we told everyone to join a company. And we said, hey, Routable is about building B2B payments, but a B2B payment is essentially a pull request, but for money. And this has been our core truth for making really good integrations and really good business statements. And that's one of the big things that they do for us. They help us hire. Integrations are intricate and they attract a certain type of person. They're not simple. They have a lot of gotchas. And at the end of the day, at our companies, we celebrate the challenges that come with integrations. And we have put together a group of people that are really oriented towards integrations and towards figuring out how to send data between platforms the right way at the right time. And then one of the biggest things too is when we interview people at Routable, which is what this event is for, we really talk about integrations and ask people how they think about them and ask them what interests, why are integrations interesting to them. It is everything that we think about, and it is what makes us tick, and what makes our company excellent. With that, though, that is a high level of our presentation. We are going to be at 4 different rooms and really excited to talk to you all. So if you have any questions about building integrations, current integrations at your current work, or just how Routable works, just give us a shout and join one of our booths. Thank you.
Omri, and last up of the major tech talks is we have Brett and Matt from OneSignal. You guys want to take it away?
Hello, everyone. My name is Matt Tiller. I'm the VP of Engineering here at OneSignal, and I'm joined with my colleague Brett to talk to you about how we use Rust to scale our infrastructure efficiently. So to start us off, I'd like to give us a brief overview of the company. So OneSignal was founded in 2011 through Y Combinator, and we are the market leader in customer engagement, powering mobile and web push, email, and in-app messaging. We're used by over 1 million developers worldwide and send a whopping 7 billion push notifications each day. We have about 60 employees located in our 2 offices, San Mateo and New York. And I'd like to give you a little bit of an overview of our messaging capabilities. So we're most likely well known for our push platform, mobile push, where we provide a very SDK-centric approach. We provide iOS and Android native SDKs, as well as SDKs for higher level technologies like Flutter and React Native. We also provide web push functionality, and we're actually present on 4% of the top 10K websites in the world. And then if you go even deeper in our messaging capabilities, we also offer in-app messaging, so allowing marketers to send screens down and workflows without having to roll app updates. We're continuing to add more and more messaging capabilities, including email and SMS. So to frame up the technology challenges that we'll be discussing today, a bit of a timeline. We were actually founded in 2011 as a gaming company and released a number of games, including my personal favorite, Fat Squirrel. As we worked on these games, what we learned was that there was a need for a developer-centric push platform. And so we actually built one ourselves and eventually pivoted the company and changed the name of the company to OneSignal. So we raised our Series A in 2017 and our Series B in 2019. And today we continue to grow our team and expand our business. And so that actually brings me to some of our technology challenges, for which I will hand it over to Brett to talk to you about how we use Rust to solve some of these interesting problems.
Hello, everybody. I'm Brett Thomas. I'm the engineering director for the backend team at OneSignal. So we're the people who actually get to send all of those notifications that Matt was talking about. Our problem was, of course, a good one to have, which was that in early 2016, we were growing incredibly quickly. It became clear that our current solution for delivering messages, which was a code base written in Ruby, wasn't going to be sufficient to the task. There were two big constraints we had from this technology choice. First, and most obviously, is a dynamic language. There's runtime overhead associated with a lack of pre-compilation. Secondly, because of its dynamic nature, at its heart is a single global interpreter. And like a lot of dynamic languages from its time period, Ruby has a global lock on it, meaning only one thread can be executing the global interpreter at a time. This makes CPU-bound Ruby applications like ours effectively single-threaded. At this time, we were peaking at 1,000 notifications per second on a single core. This gave us a throughput of about 1,000 notifications per core per second, and only about 250 seconds on average. The obvious solution was simply to buy more cores, but we knew that if our business grew the way we wanted, we couldn't afford to pay for and run that many hosts, so we needed to come up with another solution. We had a number of goals in mind for this project. We wanted a compiled language for extra speed. We wanted it to be memory safe, so we didn't have to spend a lot of time worrying about memory management. But at the same time, we also didn't want it to be garbage collected because of the high performance under high load we needed. We wanted strong typing to avoid typing-related runtime errors, and strong threading support so we didn't have a lot of per-process overhead. We wanted it to run fast, but we also needed it to be fast to implement because we were quickly running out of runway on the existing systems. Our solution? PHP. No, actually it was Rust. That cute guy there is Ferris, the Rust mascot. We felt Rust had a number of unique advantages for exactly what we wanted to do. As a compiled language, it allowed building very well-optimized binaries for our target environments. It's truly multi-threaded. And as we learned from later experience, it has some attributes that we feel really help us develop quickly and safely. Or, as our CTO Joe Wilm put it, move fast and don't break things. Language attributes let us be confident we're avoiding data race conditions. The error handling model makes it more difficult to sweep exceptions under the rug and requires developers to think about corner cases in advance before they cause problems, which is something that can happen in competing languages. It has built-in memory safety, as any recent language will, but without garbage collection, which can cause problems when it suddenly happens on a loaded system. And obviously, and famously, Rust strong typing lets us avoid whole classes of errors to begin with. The biggest obvious concern with picking up Rust in early 2016 was that it was, at the time, a very young language. While it first appeared in mid-2010, it was only beginning to make real inroads in 2016. The first Rust conference was that year, for example. While there are some obvious risks of new language, no one wants to be the first penguin off the ice floe, there are perhaps some potential downsides that might be less apparent. Modern software development is often about leveraging the work of a generous community, or gluing stuff together you don't understand, in XKCD's phrasing. When you pick a really young language for your system development, you may end up spending a lot of time writing fundamental libraries rather than actually working on the parts of your application that are driving your business. So that's a big risk you have to look really closely at when evaluating switching a core part of your technology to a young language. As we all know, the best software iterates quickly. That way you learn from your mistakes without having to throw away a whole bunch of work. Well, the best programming languages grow the same way. But that means the way you do something this year may not be the way that you do it next year, and the foundation you've built your code on can shift suddenly. If you're going to adopt a new language, you have to be committed to being an active watcher of its change and growth, and recognize you may need to occasionally refactor your own code to keep up with these changes. For example, when we first implemented asynchronous processing, we used thread pools and channels. Over the next few years, we moved to the Future 0.1 ecosystem and wrote manual state machines to implement Future, and we used huge chains of and-thens to write more procedural-like chains of Future execution. Among other things, this resulted in a lot of copy and pasted code, which is never a good software development practice. While it was usable, it was a management and development headache. Thankfully, in November 2019, the async await feature stabilized in Rust 1.39, which lets asynchronous futures be written in a very similar fashion to synchronous code. As you can see, this allowed us to greatly simplify the code needed for common patterns in our system. However, it did mean that some work in going through and cleaning up the older code, so that's a trade-off you have to keep in mind for being on the bleeding edge. While the changes in Rust over time gave us some growing pains, there are some real improvements we've seen over the years. From the beginning, it let us build robust, performant systems without a lot of cognitive overhead worrying about safety. But as it's grown and matured, we've seen the number of things get even better. Rust Analyzer goes even beyond the tooltips, definitions, error warning lit, highlighting they're now a minimum standard in IDE, but also includes great refactoring support. Compiler speed has improved. It's not yet caught up to Go, and at the end of the day, the performance of the executable is more important than the compile time, but it's a nice quality of life item for developers to allow for rapid turnaround of testing changes. We're now using a stable version of the compiler. That's right, when we began using Rust, we needed a feature, custom derive, that was feature gated to nightly. It was very nice to be able to move to a stable version of the compiler. As we mentioned, one of the challenges of a new language is a lack of library support. A big one for us over the past few years has been the improvements in the Redis RS packet, which added future support, and Tokyo Postgres, which added support for asynchronous execution of Postgres queries. So how'd it go for us? We've gone from 20 million messages per day in 2016 to over 7.5 billion today. The peak number of messages delivered has gone from 1,000 per second in 2016 to 6 million today, a 6,000 times increase. And we've done that without blowing our hardware budget. We do all of this with just 120 2.2 gigahertz CPU cores, a mix of Intel and AMD, which means that our peak, we are doing 50,000 messages per core per second. If we simply bought more cores as a solution to this growth, we'd need more than 5,000. Fundamentally, we feel our choice of Rust has enabled our business to grow quickly without busting our hosting bill. It also enabled us to develop software we're extremely confident in, which is important for us running at this scale. Remember, if our code has a 1 in a million bug in it, we're hitting it nearly 250,000 times a month. After this success, we've been expanding the use of Rust through our backend stack. We use Kafka internally to distribute our workloads, and we've quickly started writing our new Kafka consumers in Rust to reduce our hosting costs. And generally, anytime we've had the opportunity, we write new backend software in Rust. We've been particularly delighted with the way Rust makes it easy for us to write high-performance, forgettable software. Forgettable in the sense that once we build it, it runs reliably, we stop thinking about it, and move on to the next task. One concern with a new language like this is hiring experienced developers. But we found that new developers have heard of Rust and are eager to learn it. It's not so different from other languages that it becomes a major blocker on getting new people up and running. Rust isn't necessarily the solution to your problem. Hopefully our story has helped you in understanding our experiences and the challenges and successes in adopting a new language early in its history. Even if Rust isn't your solution, I hope our experiences in evaluating new technology could be more generally useful to you. And of course, if you're interested in working with Rust at scale, we're always looking for more developers to help us out. We have several people waiting to talk to you in the breakout booths after this presentation. Thank you for your time today.
Thank you guys so much. The next step is to go through these 1-minute pitches. And so we'll start with Jerry from Welcome. All right.
Thanks, Ryan. Hey, guys, my name is Jerry. I'm from Welcome. I'm one of the co-founders, and Welcome is a virtual events platform that you're using right now. So the founding team, we actually used to run in-person events, big conferences. And so when COVID first started, we were like, you know, there's really not a platform out there that helps us run the type of events that we would want. So being product people and engineers, we built it. And that's what you're seeing here today. So today, Welcome runs the most baller virtual events in the world, from CEO summits to celebrity galas, and of course, Y Combinator. We just raised our Series A, and so we are hiring across all roles. So if you want to push code in the morning and do customer development with celebrities in the afternoon, come to Welcome.
Hi, everybody. Can everyone hear me all right? Excellent. So I'm Steven Grabowski from Gordian Software. We're building an API platform for the airline industry. So our customers are travel websites like Priceline, Ctrip, Expedia. If you're running one of these companies, you basically need to integrate hundreds of APIs today. So what we're doing is we coordinate all of those 100 APIs into one generic API format. The secret here and how we do it is we've designed a generic kind of integration factory where we can scalably integrate 100 different APIs into our format without needing to in-house all of it. So we can get folks like Priceline to market super fast. So in terms of our customers, we're working with some of the largest brands already. So Kiwi's a good example, Priceline's a good example. We're doing this with 4, 5, 6 of the top 10 travel brands in the world with a team of 7 people. So we're extremely overwhelmed in terms of our customer demand, and that's why I'm here talking with you today. We're hiring back-end engineers who are going to resonate with our values. So our values are freedom, impact, and ownership. So we're looking for people who want to really understand the business context, are excited about owning things end to end, and moving extremely quickly. So if that sounds interesting and you want to learn more, join us in our booth. Thanks.
Hello, everyone. I'm Wen. I'm the co-founder and CEO of Sparking. We are a YC Winter 15 company. Most people don't know that in the US, we have 250 million cars, 800 million parking spaces, and consumers like us still struggle to find parking spaces. The supply side of the inventory is not digitized. So what we do at Sparking is we work with those people who ever own or manage parking assets to provide them enterprise software solutions to help them to digitize their parking inventory supply. Today, we work with just north of 2,000 parking sites across North America. And out of them, we work with big landlords such as Brookfield Properties, Tishman Speyer, all multi-billion-dollar landlords, as well as municipalities such as City of New Haven, City of Miami, City of Houston, City of Santa Monica. Our technology is 100% cloud-based, and by now, we've built out pretty much the largest data cloud for the parking industry in North America. We also pushed out our first dynamic pricing engine, seeing more than 100% of revenue increases for our clients. We have multiple openings on our engineering team, primarily focused on backend and data science. Check out smarking.com/careers.
Hi, everyone. My name is Maria. I'm the founder and CEO of Sinai Technologies. And Sinai is a decarbonization SaaS platform that helps big corporations to put a price on their carbon emissions, manage carbon taxes, and ultimately help them to reduce emissions in the most cost-effective way. We have customers such as ArcelorMittal, the biggest steel producer in the world, Brookfield, and most recently, we just closed with Siemens, the big manufacturing German company. For one customer only, we are helping them to save over $3 billion per year while reducing 13% of their carbon emissions. This is one study case that we recently closed. I've been working in sustainability for almost 15 years now. And Alain, my co-founder, was Uber engineer number 12. We are a team of 10 people right now, and we are looking to hire one designer and one backend engineer. So come talk to us in our booths. Thank you so much.
Hey, I'm Avery from Drip. We're an all-in-one tool to run your restaurant. We're super early, just my co-founder and I, but our product is already shipped and used nationwide. Now is a really fun time at Drip. We just closed our first round, and we're trying to build out a rocket star team. Every hire right now has a huge opportunity to impact everything we do and ship to potentially hundreds of thousands of restaurants in the United States. Because of this, we're actively looking for engineers that want strong product ownership. Everyone in our company talks with our customers almost every day. We build our product specifically around communicating with our partners. We're strong believers in finding your own work. We don't believe in PMs and 100-item backlogs, but what we do believe in is that you should be able to be in charge of what you work on. Want a feature to exist? Talk to a restaurant, see if they want it, hack together a prototype, and ship it the next day. To give you some context, you'll be joining a team of several-time founders and our most recent hire, an ex-Googler. We need the last piece of our puzzle before we take off, and that piece could be you. If you're interested, email me at avery@drip.is or come to our hangout session after. Thanks.
Hi, I'm Manmeet, the co-founder of Tuning Labs, and we help companies like Unilever and Pepsi develop better products. You'll be surprised that the products like shampoo and detergents takes millions of dollars and years to get developed properly. Turing does this in a matter of weeks using data and top-notch machine learning and AI algorithms. Few of the world's largest brands and fourth largest retailer on the planet is using Turing to develop products that you and I consume every single day. But our current version is really breaking, guys. We are building an enterprise-grade software, and we need to, have the warriors, courageous engineers who can build the software and compete with legacy players like IBM, Microsoft, and SAP. We are very well funded, and we have great customers. We have great demand, but we just need to now build a great product as well. We have amazing product market fit. Thank you so much.
Hey everyone, my name is Ryan and I'm the co-founder of Arist. Arist is the world's first text message learning platform. So we work with Fortune 500 companies and organizations like DuPont, GE in the state of California to create, deploy, and assess text message courses. 95% of people read a text message within just 3 minutes of getting it. So as a result, we help create and deliver training content to employees in a way they engage with, they actually read, and they really love. Our long-term vision is to deliver critical knowledge and training to anyone in the world, regardless of traditional learning barriers, one text or WhatsApp message at a time. Backed by research from Stanford and Harvard, text message courses see about 10 times the completion rates, satisfaction rates of other learning mediums, and we've learned a lot about how to best teach someone in so little content. We just finished YC's S20 batch and closed our seed round, and we're now looking for full stack developers with experience in Node.js and experience in enterprise as well, and really just a love of learning to join our really fast growing team. Arist is an awesome and fun place to work. Check out our post on Work at a Startup. I'll be in the lounge after, or reach out to me at ryan@arist.co. Thanks so much.
Hey everybody, I'm Danny. I'm on the recruiting team with Retool. Retool is a winner session 2017 Y Combinator company. And for those of you who don't know, Retool is a very fast way of developing internal tools. So Retool allows you to drag and drop components like tables, drop-downs, text inputs, things like that, so that you can develop and assemble your internal tools or apps very quickly. You can also write code, custom code on top of Retool, either manipulate the data in some way or to get your tool to look and feel like the rest of the way that you want it to. We're working with companies like DoorDash, Brex, and Coinbase, helping them spend less time developing tools from scratch and more time operating much more efficiently. We had a fairly large Series A led by Sequoia. We're now investing that back in the business. That's why we, myself, Ariel, and Amanda are here. That's why we're excited to chat with you all. We're around 40 employees right now, like 14-ish on the engineering side of things. And a major emphasis right now is on engineering hiring. So I'm excited to chat with you all, but we also have opportunities in other parts of the organization like operations support, marketing, sales, things like that. So stop on by a booth. Excited to meet you.
All right, those were all the talks and the pitches. Thank you guys so much for making time. Make sure that you go to the lounge. Everybody is now waiting over there to chat with you, to have one-on-ones, to meet, so you can learn more about the technologies in the business. I want to do a quick shout out to Tiger, who's been behind the stages. He actually works at Welcome. He's done a fantastic job to make this happen. You get to see his new haircut, and he looks great. Thank you guys. Welcome has been such a great tool and great partner in taking this. And then when we do more of them, hopefully we can make this a great experience. So that said, go on over to the lounge. You don't want to hear from me. If you have questions, I'll be lingering about. We don't close the doors until everyone leaves because we want to make sure that you can talk with everyone that you want to. Go for it. Thanks so much.